Hi guys, welcome to another LivinginSAtv video, David here. So today we are going to the Hartebeeshoek base right here in Gauteng to see and understand and for you to learn how important are the South African National Space Agency operations in our lives. Don't you believe me? Stay tuned.
Welcome to the South African National Space Agency space operations. I'm going to take you for a short tour and we can discuss a few things here and give you some of the history and why we're in such a perfect location. So follow me. So unfortunately everything here has a national key point and everything is locked up, so we have to enter ourselves. This is our foyer. Where we do have some of our exhibits of what we've been in for around the last 60 years. We started in space around about 1958, which leads us to about 66 years in space for South Africa, and became a space agency in 2011. Okay, so we can go down the passage and see some more of the memorabilia that we've gathered over the years. So South Africa was involved in as early as the 60s, became part of the planned moon landing and brought a lot of that technology to South Africa to learn and to track spacecraft for NASA and then the likes of the USA going to the moon. Just to give you a further look, this wall depicts launches and operations we've been involved in since 1983. We've done over 600 launches and spacecraft TT&C for international customers, and the board depicts that, and every one of these is an operation that has taken place. This board is just, this wall just gives you a lot of old memorabilia of what a spacecraft looks like. Typically one of South African spacecraft up here, which is called, CubeSat, a 3U CubeSat, and South Africa has launched those and which are presently functioning. Some of the older stuff, one of the first laptops we had, and for those that don't know, that's just the old telex machine. Let's go further down the passage. So as you walk down the passage, we walk into our operations room, and some of my other colleagues will take you through that. Let's go outside. This gives you a feel of the array of antennas we have. Presently we have 84 antennas on site. A lot of people call them satellites, but unfortunately the satellite's in the sky. The antenna does the tracking, and therefore we have so many on the ground tracking international and national spacecraft for international companies. Okay, so let's walk up to my favorite spot from where I can see most of the equipment and give you some background. So from this location where I am now, you can probably see most of our antennas, some of our wildlife, and this antenna behind me is the oldest antenna on site. This antenna was erected in 1963 and became part of the furniture. It still operates as of today. It's been maintained several times on the electronic side because that changes periodically, but the mechanics and the infrastructure and the gears, that stuff is all intact and still working today. As you can see, we're presently busy tracking a spacecraft that was launched on Monday evening. So basically, to give you some of the background of the site was built from 1958 to 1976. The site was used for NASA. It was the Deep Space Interferometry Facility, as well as JPL, Jet Propulsion Laboratory, and the site was built for the whole moon landing and going to the moon. We tracked many things in that period of time, probes and stuff that went to the moon for intelligence, so that the rockets and the astronauts could get there safely at the end of the day. In any case, in 1976, NASA withdrew. This site then became redundant. We had to find something to do. However, we learned the skills in those years, and then took a strong decision to get involved in space for South Africa. So what we did is we said, let's build a space capability in South Africa from 1976. We then took a decision to use the station for Earth observation. We tracked Earth observation spacecraft from Landsat to Spot to many others as early as 1986. In 1998, we also took a further decision to get involved in tracking the spacecraft and doing TT&C, which is telemetry tracking and command. That enables us to put other people's spacecraft in orbit and to track other international spacecraft when needed. And as you can see, the business has grown extensively since 1998 till where we are today. We started in as early as 1998 with 3 antennas. Today we have 84 antennas on the site. Collectively, we've done over 600 passes and putting spacecraft in orbit for other international clients. One of our feats is why this station? Well, it's about the location in the southern hemisphere of Africa, and that makes it key, because most of your spacecraft are in an elliptical orbit, or in a low Earth orbit, or in a MEO orbit, and we have the privilege of sitting in the southern hemisphere and seeing the geo arc, which gives us the ability to track all geostationary spacecraft looking into the northern hemisphere. What also makes the station unique is the height above sea level, the weather conditions, as well as the skills of the people that we have in South Africa, which have learned these skills over many years. It also lends itself to expansion out in the field. We are also in the process now of building another ground station similar to this for deep space capabilities. The station won't be located here, but will be located in the Karoo, which then gives us better weather conditions for deep space, and we want to call it a more silent environment when it comes to radio frequency noise. The station is presently being planned, designed. We'll probably have it operational around about 2027.
Hi everyone, my name is Betty. I work in the operations room. I work as a shift lead operations technician. So today I'll be taking you guys inside and showing you what is it that we do. I hope you're gonna enjoy. So come. Yes, you can come in. This is our mission control room. This is where we mostly view when we check the satellites using the antennas, and also for preventative maintenance. I know where to check if you want to know which antenna has got problems. So you guys can come in with me so that I can show you. Yes, these are my colleagues. Hi colleagues. Yes. So like I said, we do preventative maintenance. So we usually use this visual data center application to check if ever there are any alarms. Since I can't always be outside to monitor the antennas, so I use applications like this one, visual data center, or this one up there. It's for network monitoring. So whenever there's an alarm, maybe there's some high temperature in the antenna, I'm able to see it here. Let me open it for you. So it's different antennas. So as you can see here, there's no alarm. So if ever maybe there's an alarm, I'm gonna click here and then it's gonna show here if ever there's anything that needs to be attended to. So normally on a daily basis, we do maintenance checks which is part of our preventative maintenance. We make sure that we check the antenna structure, we check the temperature, we check if ever there's any electrical faults inside the antenna. So prevention is better than cure. So by doing that, we know that we also cutting costs for the company. We're not gonna have problems whereby we have to fix or we have to buy new equipment. So rather they get fixed than replaced. So yes, that's what we do. And again, inside here we also track satellites. We use different antennas. As you can see, it's different screens in here. So each and every antenna or each and every station here is dedicated to a certain antenna that's gonna be tracking satellite at a specific time. So normally you find that I'll be using the 7-meter antenna. So I know I'm gonna come to this station and run the application, like configure everything and also position the antenna for AOS. So there's a scheduling that we get from the clients that we set up, that makes us that's gonna lead us into setting up the supports for the day. So I know by this and this time I'll be tracking which satellite and from what time I'll be positioning my antenna to. So that's mostly what we do in the operations room. We deal with international clients, so we have to always be on our A game. There's no time for any error, give the best of our ability. So yes, I started as an intern, and through experience I've learned, because it takes time. There are clients coming and some leaving, so per their requirements, you should know what is it that they want, what is it that's required from them, what is it that they want to ingest. So that's what we do here.
Oh, hi, my name is Cindy Siwesono. I am an operations technician. I just started not long ago. Okay, what I normally do on my daily basis is I track satellites, collect all the data that is there, but not physically, of course. I don't go up there and collect. We use antennas to receive the signal, which is filled with all the information that we need, and then it's going to be converted to an actual imagery or videos. So I would be patching here where I need to know which antenna I will be using and which polarization. There's a lot of technicalities in between, but to round it off, what I normally do is just switch on where I'll be storing my data, and then which antenna I'll be using to collect that data from that satellite. And then there's settings where we need to ensure that the frequency is the same as the one of the satellite. That is basically it.
Hello, I am Bonolo. I am an electronics engineering and service trainee here at SANSA Space Operation. I was born in Mpumalanga, Bushbuck Ridge, and I'm very grateful for this opportunity that I got to work here at SANSA. I didn't know about this space before I started. I only knew about it when I came for my interview. So here we do a lot of things, like monitoring there. We do have a telescope in house for tracking space debris and junk. So we need that. We use it when it's -8 degrees. So that's when we start. We can't start when there's still sunlight. So we have to wait until it's at night. That's when we can start the work. And we also have 360-degree camera view of the whole site, which it shows the cloud coverage, because also we have to take in mind that the telescope is not weather resistant, so it can, if it's subjected to water, it can malfunction.
So hi guys, so my name is Musa Chavedi, and I work here at SANSA Space Operations, and I work as a electronics engineering technician intern. Okay guys, so here I'm gonna show you our different types of antennas. So most of these antennas that you'll see over here, they're what we call them geostationary. So geostationary is they don't really move. Well, they do move, but they move in the sense of at the same speed of the Earth. So pretty much they don't move. So you'll see them, they just stay as they are tracking, they're working perfectly fine, but they just stay as they are. And then if you look over there on that side, we have our moving antennas, which are like they are tracking our S-band, X-band, so on and so forth. These ones are the ones that we control in the ops room. Okay guys, so over here we have our dome antennas, what looks like, I don't know, mushrooms or whatnot, but essentially it's the same as those antennas that you saw that are open, but they are covered because you know, to protect it from things like bad weather conditions, disturbances, other arrays, things like that. So this dome is there for protection.
Good afternoon, good morning, wherever you are in the world. I'm Gladys Makakula. I'm a project manager here at Sansa Space Operations. Yeah, so Sansa Space Operations, project management. You might ask yourself, how did I get here? Basically, my first time here, I came here to be mission control specialist on the very first South African government satellite to be launched to ManilaSat. Why they chose me specifically? I used to be an intern, and then I worked at Sunspace and Information Systems, the company that built the satellite. So, I mean, then they had to get me to come and mission control the satellite. Fast forward, satellite there in space, malfunction. You know, space is very harsh. So after the satellite malfunctioned, I had to look at what to do here. I did a bit of science communication. After science communication, and then I ventured into project management. And yeah, in the project management, basically you might ask yourself, what do I manage? This is one of my projects here. One of it's an international client's antenna. So Sansa Space Operations, over and above the very amazing work that it does, we host infrastructure for various clients. Why? Location, location, location. There's only one RTPS hook. So yeah, so you might ask yourself, the antenna, it doesn't arrive like this, it arrives in boxes. So when we get a request from a client to build an antenna for them or a ground station, we then check for what needs to go on here. We check how what they are going to be receiving, how will it affect the rest of the equipment here, and also how the rest of the equipment will affect that station before we determine what position to put it at. We do some geotechnical investigations, and then we do, as I said, radio frequency interference surveys, and then we appoint engineers who are designing this beautiful work there, and then we appoint contractors. By the way, the engineers and the contractors are local, so we get to create employment for many people here in South Africa. And then at the end of the day, we assemble this antenna, and then it tracks satellites as they pass our airspace.
Side. I'm Simon Chaba. I'm the ICT Manager for Sansa Space Operations. So I'll be taking you across to see what Sansa is doing. Here we are building the new server room so that we can be able to accommodate a lot of servers that's going. We normally don't want to bring new infrastructure without having to populate with the rack. So what's going to happen in this area is that we're going to have a lot of empty racks, and then if we want to scale up, we just populate the racks which are already fully connected on the network. So while we are here, I'm going to introduce what's the purpose of Sansa ICT. So what we do is we provide backbone data connectivity to our clients. So Sansa, we're having hosted customers on site, and what we do is we provide them with internet access to be able to transmit their data, which they track and collect from the satellite. So they get data from the satellite and store the data locally on the local drives, and to save space, data must be transported from the site within 24 hours to the destination location. And as Sansa ICT, we provide the backbone connectivity. The service must be up 99.99% availability. Therefore, what we do is we make sure that we provide multiple redundancies on the ISP level as well as on the on location, because the route, they must follow diverse routes when breaking out of the station. You remember I was talking about the redundancy and the network connectivity. So what you see behind me, that is the backbone of connectivity. So all the traffic, all the bits, all the zeros and ones, they get out of these systems and then they go out to the internet. What we have here from this area, this location, is that our data is routed through Terraco data center. We've installed a fiber connection which consists of the physical cable, the physical fiber. Then we have what we call the DWDM, which is the actual hardware which is lighting up the fiber. That hardware on a single fiber is doing what you call multiplexing. So on one fiber we are able to provide bandwidth capacity of 40 multiplied by 10 gigs. So we can provide that capacity from here to Terraco. From Terraco, why we go in there is Terraco is the carrier hotel. That's where you can be able to break out to the internet from multiple ISPs. All the ISPs obviously nationally are hosted in Terraco. So from here we connect to Terraco, and we also have a connection through Pretoria via the South African National Research Network, which is the TNet. That connection on its own, we're having 10 gigs, 2 links of 10 gigs. So we have redundancy on the physical fiber, and we also have redundancy on the ISP, which gives us that capability to be able to service our clients which are hosted here on site. And then the other service that we provide is we provide our clients which are hosted here, and also for our customers here, we provide building monitoring and environmental monitoring system, and also the integrated security systems. What I mean by that is that we monitor the environment, temperature, humidity, and all that. So we monitor that for the clients as a service to them. And we also provide intrusion detection, monitoring, and all that, and also the CCTV monitoring. So if there's an activity, if a person opens the room, you will be able to pick up who went into the room at the time, and we save that image for in case of if there was unauthorized access, then it can later be investigated and all that. We hosting clients, and which means they are connecting to through our network. So then the cybersecurity thing comes into play. So as ICT as well, we look after the cybersecurity and the network to make sure that only our clients which are hosted here are the ones going through our network, and also to make sure that we don't restrict. So we cut the balance. We don't restrict our clients' connectivity, because they still need to have the freedom to be able to conduct their business, but we don't want the hackers to be able to gain access to our infrastructure or the client's infrastructure. So we also offer the cybersecurity connection as well, protection, as well as by implementing firewalls, security appliances, and all that on the sensor infrastructure. And then finally, we provide communications, voice communications for our internal clients between the directorates, and also we provide end user support, which means we sort out the end user computers, the normal stuff, file and print sharing, the internet connection, and all that.
So guys, this is the back part of the base. It's actually beautiful to get here. You can see also a lot of wildlife. It's beautiful, eh? Look at this.
Hi, Willem van Rooyen. I'm the electrical supervisor on site. here at a power station for the SANSA. We are required by our contracts life requirements for our GPS to be available 99.99% of the time, power availability. Also, the purity of our power is better than Eskom can supply us. So we are using a Euro diesel system as our primary backup supply. It's a dynamic UPS with a diesel generator backup. Once we lose reliable power or quality issues with Eskom power, this system takes over and gives us clean power. So we use filtered power on our site for our customers, and we recently installed a backup system of a bigger normal diesel generator. So if our Euro diesel fails and Eskom fails, we have got our third system of power supply to the top. We also have a redundancy system of 2 power supply lines running to the top, whereas we get 11,000 volts from Eskom, we take it down to 400 and filter it through our Euro diesel, and then we take 2 transformers and we generate our own 11,000 volts to the top. At the top we have got several transformers taking back to 400 volts.
My name is Mohammed, and I'm a shift lead technician here at SANSA Space Operations. So I'm just going to be demonstrating a radio frequency survey test. So I have an antenna, I have a tripod, and I have a spectrum analyzer. So this antenna will be tracking S-band frequency. So I'm just going to move this antenna around clockwise. So the aim of this project is just to scan the horizon, just to ensure that we don't to maintain our RF environment. So this is south position that I'm in now, so I'm just going to rotate the antenna and monitor with my spectrum analyzer to see any peak of signals. And once I see a peak of a signal, then I will just take screenshots, record the signals. For example, at that frequency we have some interference, and that frequency around 2.4 gigahertz. So these screenshots will be used in our analyzing mode to analyze if this interference is internal or external. So this is basically the test. And of course, these screenshots will also be saved in accordance to what azimuth elevation angles that the antenna currently is pointing at. And yeah, and then the same will be done at this angle. And that's basically it. So it's just one rotation, and the data recorded here will be analyzed on my spectrum analyzer as to when or what direction the antenna was pointing, and that's the data we use to analyze to see if this signal or these interference, whether they are harmful, coming from external outside our site or internal within our site. Thank you.
And there you go, guys, we now done with the video. I hope now you understand better what SANSA does and how important the space program is in our daily lives. Again, guys, I hope I can show you more SANSA bases around the country. Don't forget to share, subscribe and destroy that like button, and I will see you in the next LivinginSAtv video.